Today we will do a numerical on shear force diagram and bending moment diagram. So last two class was about the introduction of shear force diagram and bending moment diagram. So today let's choose a numerical which is very basic, which is having a cantilever beam with a point load at free end, having 5 kilonewton and a moment of 5 kilonewton meter. The distance of moment from the fixed support is 2 meter and the distance of point load from the fixed support is 5 meter. So let's go for a free body diagram. We have to do first a free body diagram where we will change the fixed drawing according to our convenience. So fixed support, as we know, we have if we have fixed support, the reactions are three, that is vertical, horizontal and moment. But for this time we are taking two reaction, a moment and a vertical one, because there is no horizontal or there is no x direction any reaction. There will be no x direction reaction. Okay, so first we have to find out the reaction. What will be the reaction, because only the reaction is unknown. So let us adjust the free body diagram at the corner of the board. Let's start the solution. First, step 1. Starting with step 1, let's do, as I have said, summation of fx means force in x direction will be 0. There will be no forces in x direction, but forces in y direction is 0. So first, two y direction reaction is there. So first r is upward. So for upward, remember upward is plus. Okay, so writing as it is r, and the 5 kilonewton point load is downward, so minus. So r minus 5, which is 0. So r equals to 5. So we got the reaction which is r equals to 5. So now for step 1, you remember one thing. Let me finish the summation 1. Summation of moment. Summation of moment equals to 0. We have to write it first. Then how many moments are there? First is this moment mr, because this is a cantilever beam, the moment will be there. So the first is mr, which is anti-clockwise direction, that's why it is minus. And the 5 kilonewton meter, it will be plus because it is clockwise direction. Okay, for now the point load which is coming clockwise, that's why it is plus, and 5 into the distance will come, so 5 into 5. So from after simplification we will get mr means moment in rotation will be 30 kilonewton meter. Okay, so we got moment, we got reaction from step 1. Now from step 2, which is shear force calculation. So for shear force calculation, all the forces that we have to calculate, there will be no distance or no moment. Every moment we are going to eliminate. Okay, so let us first give name for every points A, B and C as I have given. So the first step is step 2. For step 2, the first thing you have to do is we will start from A. Okay, A, B and C. So let's write just before A. Okay, just before A it is 0. As you can see, just before A it is 0. Okay, the point before A there is nothing, that's why it is 0. So the next is at A. Okay, at A is how much? At A is force. In at A we have a 5 kilonewton force, but it will be, it is downward direction, that's why it is positive. Okay, for step 1, if it is downward direction it would be minus. Okay, so just before B we have a one force, only one force, this force only we have, so it will be plus because of downward direction. So let's write downward direction plus. At b, at b, what we have, b, there is moment, so there will the moment will not be count. The force that we have at a point a, it will come plus 5. Okay, 5 kilonewton. In shear force, we won't consider a moment. I'm writing it, no moment to be calculated. Okay, in shear force. So just before c, we have only one force, that is just before c. We have only one force, that is a, which is 5 kilonewton. So at c we have the force, means as a reaction we have force. So we already found that reaction is 5. It is upward direction, that's why it will be minus. We already know R is 5. So plus 5 minus 5, which is 0 kilonewton. So we got this shear force calculation. All the shear force values we have now. So now go for the step 3, which is bending moment calculation. Okay. Same for the bending moment. We will use the same free body diagram, and the calculation will be almost same, but moment we will calculate. Okay. At a, sorry, just before a is how much? It's 0, obviously. At a is how much? It is 5, but as we are calculating moment, so we need length, means we need distance. So minus 5, it is downward, that's why it is minus. In a bending moment, for downward it will be minus, so minus 5 into 0, there is no distance. Just before b, so just before b, what we have, minus the downward distance, but from b to a there is 3. Okay, so that's why 5 into 3, which is minus 15 kilonewton meter. At b minus 5 into 3, as we already know, and minus 5, from where this came, at b point we have a moment which is minus 5 because it is clockwise direction. Okay, just before c now, just before c, as you can see, minus 5 will be the force and the distance is 5. So minus 5 into 5, and minus 5 is the b point moment, which is minus 30 kilonewton meter. At c, okay, at c what we have, first of all we have 5 into 5 minus 5, which is just before c1, plus 30. Plus 30 means we calculated summation of moment, which is 30, which is anti-clockwise, that's why at this point of time the anti-clockwise will be plus, so this is 0. So now let's we have the values at the right hand side, shear force calculation values, bending moment calculation values. So we will draw first the free body diagram. So the free body diagram will be as I'm writing, as I'm drawing. So first let me write the points. Okay, a b c, we have to write a b c so that it will be easier to understand. So for, as you can see, the shear force just before a is a, at a is 5, so plus 5, at b is plus 5, at c is plus, at c is 0, but just before c is 5, so we will connect the line, it will be plus. Okay, as I am drawing it is shear force. So how this shear force diagram is coming, it is constant, it is coming constant, right? Now bending moment diagram, constant but positive constant. Okay, so now bending moment diagram, for bending moment diagram what we gonna do, just before b we will draw, just before b the point 0 we'll draw at b only, just before a we will draw at the point of A only. Okay, so as we have drawn in shear force diagram, we will draw it in bending moment diagram. So just before B and at B is different, minus 15 and minus 20. So there is a difference. Okay, sudden change. So and just before C is 30, minus 30. That's why it is below the line. And at C is 0. Ultimately, it is connecting to 0. As it is point load, that's why as it is point load, that's why what we are doing, what we are drawing the line inclined. Okay, linear line. So this was the bending moment diagram. I hope this was easier one. If you thought I was a bit faster, please pause and watch the video. Thank you.